Alright, so that was pretty simple. But I gotta be honest, call me spoiled, but loading 600 records taking a full minute, it concerns me just a little bit. Because, okay, dim product isn't that big of a table. We only have 600 total products in the data warehouse. But what about loading sales? We potentially have hundreds of millions of actual sales records. So in this next example, let's see what it would take to load. Maybe we don't have time for hundreds of millions in a simple demo, but let's say, how about a 250,000? In a dimensionally modeled data warehouse, there's going to be a lot of joining between this sales table and a lot of the other dimensions. Really, this sales table is kind of the heart and soul of this data warehouse. So for this example, what we're going to do is we're going to load pipe delimited instead of comma delimited this time. I have here a sample file. And as you can see, there's quite a bit of data in here. And we want to do this in a way where we can load a lot of data really quickly. Now, interesting side note, remember back in our last demo, I said you really only need 3 clauses: the table you're copying into, the source that you're copying from, and some authorization details. Well, if you only had that bare amount of information, Redshift would be expecting a pipe delimited file. That is the default. Now, to really take advantage of the clusters that we have set up, we want to use parallelism to its utmost. Now, we do have a pretty small Redshift cluster here. We only have 2 compute nodes. And I've sized them as DC2 large, which means that they each have 2 node slices. And while we're here, also know I rebuilt the cluster this time on the US East region. That's going to be important here later. So our entire Redshift cluster has 4 node slices. So ideally, we would be loading into each of those node slices simultaneously. So what we're going to do is we're going to break up all of that data that we want to load into that fact sales table into at least 4 files, or a multiple of 4. So in that load queue bucket, I've already preloaded 4 different sales files. We have sales1.txt.gz through sales4.txt.gz. Now the GZ extension represents a gzip. That's another way we can save quite a bit of time. The copy command is able to unzip files, and by having your text files zipped, you save a lot of data that has to travel what could be limited bandwidth between that S3 bucket and your Redshift cluster. So putting our new copy command together is pretty much like last time. We're going to say copy, we have the table that we're copying into, a from clause, but this time we have more than just one file that we want to copy from. So how do we accommodate that? Well, something to be aware of about this from clause is that it's actually based on prefix. So if I type in S3, then the bucket Redshift load queue, and then the prefix of sales, it's actually going to load all files in that bucket that have the sales prefix. The prefix concept in S3 storage is actually pretty common throughout all AWS, so it's something you want to get used to. Once I've specified my bucket and the sales prefix, the next clause I want to add is my region. Remember, a bucket can be any of the regions, so the copy command wants to know ahead of time where it's going to be looking for that S3 source. And then, of course, our authorization clause, and again, we're going to use that Redshift S3 role that we created in our previous demo. Now, because those files have been zipped up using gzip, I need to let Redshift know that ahead of time. And then I don't necessarily have to put this because pipe is the default, but just for clarity's sake, I'm going to go ahead and list the delimiter as a pipe. Now, if we ran this like is, it would work, except for one problem. The sales prefix is shared among those 4 pipe delimited files, but there is a 5th file in here that starts with a sales prefix, something that has nothing to do with what we're working on. So we can't really use the sales prefix approach. And since we don't want to take the time to run these copy commands each individually, because that defeats the purpose of using parallelism to our advantage, we need to take another approach. Well, what we use is a manifest. By adding the keyword manifest to our copy command, what we're telling Redshift is it needs to go look into a manifest file to actually find out all the details about the files that we're going to copy in. How does it know where to locate that manifest file? Well, we replace the from clause with the location of that manifest file. I'll put it here as manifest.txt. Now, if you were paying real close attention, you would have seen in our Redshift load queue that there is no file named manifest.txt. So let's show you how to create that right now. First, I'm going to zoom it in a little bit here so you can actually see what I'm typing. And a manifest file is basically just a JSON file that tells Redshift details about the files that it wants loaded. There's an entries array, And then within that entries array are a number of items that include a URL and then a clause that says mandatory. If I say mandatory true, what I'm telling Redshift is that I want this to only work if all of these files are present. I could set mandatory false on some of them, and then if it couldn't find that file, it would go ahead and continue to load the others. I have 4 files, so I'll enter 4 items into this entries array, and then under the URL, I'll put the Redshift bucket and then the individual name of each file. And it's as simple as that. So I'll go ahead and save this as manifest.txt. And then I'll move back over to AWS and upload this file into that Redshift load queue bucket. Now, like the other demos, I will make all of these files available for download. So you can go in and look at this manifest file, and you can use each of these copies of the fact sales data in your own hands-on practice. All right, and then with that uploaded, looks like we have everything just like we want it, and we'll go ahead and run this again. Now remember, last time we loaded 600 records into that dim product table. It took about a minute. Using a manifest, running 4 of these in parallel, and using a zipped file source to ease that transition between the bucket and our Redshift cluster, we just loaded nearly 250,000 records in about that same amount of time. Looks like there's only a difference of about 8 seconds. Now that transfer of 250,000 records was from a bucket in the US West region to a Redshift cluster in the US East region. So not only did we load 250,000 records in pretty respectable time, but we did it from one coast all the way to the other. All right, let's do just one more demo of that copy command because there's a couple other things that I want to show you, and one of them specifically related to troubleshooting.